Great day, everyone. Welcome back. Once again, I am Ivan Brian L. Inductivo, your instructor on inferential statistics. This is the third of the three-part discussion on inferential statistics, different tests, and distinction between parametric and non-parametric tests, as well as the enumeration of the tests of differences and the test of relationship. Now we embark on the last part, which is the test of relationship. When we talk about test of relationship, most likely you will encounter in books of in statistics, they will be discussing two types here: the correlation and the regression. Now, in the correlation, you are talking about the association of one variable to another variable. However, it doesn't assume the causal relation between one to another. And in the part of regression, you are already enforcing a more reliable and more predictive relationship between the variables. So in this part, I will only cover the test of relationship in terms of correlation. Okay. So first, let's look at correlation. Correlation is the association between two variables, whether one influences the other, whether one relation or one variable has a linear relation to another variable. For example, you wanted to look whether the increase of salary also has a direct positive or negative influence or association in the increase of productivity or performance of your employee or personnel. So we're talking about relationship here. You might also look whether the increase in study hours of students might also invoke an increase in the learning outcomes of the students. So this is relationship. So when you say relationship or correlation, you're looking at a linear pattern of relationship between one item or one variable and another variable. So again, you're talking about only two variables here. So just a precaution and a disclaimer here. When we talk about correlation, you're not really talking about cause-effect relationship, but instead you're looking whether one has a similar pattern or an association, whether it increases or decreases, or expands or decreases to another variable. So again, we do not assume the causal relation, but instead we see the association of one item or one variable to another. So here's an example of the relationship that we will see. You call this a scatter plot. You try to plot in whether one individual has this uh, attribute to one variable and another to his another attribute to his other variable. For example, on the um, on the left side, you will see here the scores, and then beneath that, you will see the labels in terms of um, let's say um, incentives that they have received. So does it mean that the higher the incentive, the higher the score? So you will see here direct relation that the lower the incentive, the lower the stat test score. And then as it goes to the higher score, the incentive also goes higher. So you have here a direct relation. Actually, I will call this a positive relation between the two variables we're talking about. So you'll see here that there's a pattern, a linear pattern between the two variables. Okay. So there are two types of relationship here or correlation: the positive and the negative. The positive correlation looks at an increasing relation and a parallel direction of the two variables. So if one is increasing, the other also increases. So when you say positive relation or positive correlation, if a variable increases, the other variable also increases in its direction. If the other variable decrease, the other also decreases. That's a positive correlation. So you see there a mutual direction. But when you talk about negative correlation, the direction of the relationship is inverse. So if one increases, the other decreases. If one decreases, the other increases. So that's the kind of relationship. And usually in the scatter plot, so in the scatter plot, you see a direction going towards the right, then that is a positive correlation. If you see a direction going to the left, then that's a negative correlation. So here are examples of scatter plots. If you look at the first item here, um, this one, you see there on the top left, there's no discernible um, direction or pattern, whether tilting to the right or left, or it's not really diagonal, it's scattered. So there's no relation here. Okay. On the second item on the top right here, you see here, it's quite similar that the lines are also scattered. But if you see the lower here, the lower part, the lower left, you'll notice that there is a sort of pattern going downwards. The higher the y coordinate, the lower the x coordinate. So as it goes lower, the y coordinate, the x coordinate goes higher, which means it has a uh, tilting direction or pattern, which is quite indicative of a negative correlation. Now the last here on the right side, this one, the lower right, is in the inverse pattern on the previous. So you see here, the lower the y and the x-axis, the lower the y-axis is also, which is also indicative of the lower x-axis, and then as it increases, they are both increasing in number and in direction. So you see here a positive right tilt. So it's indicative of a pattern of a right or positive correlation. Okay. So what do you mean by correlation here? In the correlation, the most common or the parametric standard here will be the Pearson's product moment correlation coefficient. And in this case, what you're looking at is whether the relationship is positive or negative, and whether this positive or negative relationship also has that strength. Whether it's a strong negative, you see a very clear pattern going to the left, or you see a very clear pattern, a very clear straight pattern going to the right, then that is a strong positive. The stronger the relationship, the more close or closer rather the patterns or the association of both variables. Okay, so the stronger the negative relationship they imply, the or they indicate, they imply a stronger inverse relation in terms of the two variables. See, so in terms of relation, you need to look whether it's a positive or negative, and at the same time the strength of the relation. So what are the tests that we will be using? If you have two variables that are numerical, interval or ratio, so if you have, for example, scores of students in a test, and then the number of absences they are incurring within a quarter. So these two are numerical. Then if you wanted to correlate them, most likely you will be using what we call the Pearson's R, or the Pearson's product moment correlation coefficient, or the shortened version of this is Pearson's R. Or at times, if you're going to look at tables, you'll see there a small letter R. This talks about the Pearson's R. Again, this is the parametric test. Now, if your data uses ordinal or ranks, you're comparing ranks. For example, um, a rating scale from one point of view, and let's say a ranking of um students on the other side, and you wanted to correlate them, the ranking of performance, and let's say a rating scale, then you need to use a non-parametric test, which is, for this case, Spearman's rank correlation coefficient, or Spearman's rho, or the rho. It's like a letter P, okay, as an italized letter P. Okay, so when you're correlating ordinal data, you'll be using Spearman's rank. Okay, then if you're going to use and correlate nominal data, terms, categories, labels, you'll be using the chi-square tests. This is a chi-square. This is a chi-square. However, it's a chi-square test of association. Again, that's an x squared test. The symbol there. Okay. Again, for non-parametric nominal. So again, as a limitation to correlation, as opposed to regression, in correlation you are only looking at the relationship between two variables, okay, limited to two variables, and then you're looking at a linear relation. So variables that doesn't indicate any linear relation or in any linear pattern, for example, they don't have an increase or decrease, or they don't have highest or lowest or gradations, then it is not really applicable to correlate them. And then, of course, if your data is truncated, which means you only have a parcel of the scope or the range, then it's also not advisable to test the correlation. You need to see the full spectrum of the variables. So again, these are the limitations of correlation. So I hope briefly you'll understand that there are only three tests used in the test of correlation. Now, in the event that you have rankings that are similar, then most likely your statistician will advise you to use Kendall Tau. But nonetheless, Pearson's R, Spearman Rho, and chi-square test of association will be used on the test of relationship or correlation. Once again, thank you. Namaste.